Welcome to this explainer. Today, we're diving into a really massive question. Why isn't human-readable AI automatically trustworthy? And, more importantly, how can we systematically stress test its claims? We're looking at some truly fascinating research that tackles one of the absolute biggest challenges in modern machine learning right now, making sure that when an AI actually tells us why it made a decision, it's, well, actually telling the truth.
Just because an AI explains itself, should we trust it? Think about it for a second. We are rapidly deploying AI into incredibly high-stakes environments. We're talking medical diagnosis, autonomous driving, financial forecasting. Now, for the longest time, the main complaint was that AI is this impenetrable black box, right? We had no clue how it was making decisions. But today, newer models can actually give us human-readable explanations. But here's the multi-million-dollar question. Does a clear answer actually mean a correct reasoning process?
Researchers have flagged some major reliability challenges here. Just look at this spurious correlation example. An AI might totally nail a medical diagnosis, but not because it's looking at actual clinical evidence. Instead, it might be taking a lazy shortcut. It might just identify a hospital's text watermark or an NHS logo that happens to be on all the training images for sick patients. So the AI gives you a totally plausible diagnosis, but its underlying reasoning is completely flawed. It's relying on a shortcut, not actual science.
Section 1. The AI Transparency Illusion.
Okay, let's break down the danger of just taking AI at face value. First, we need to understand what we're auditing. It's an area called Concept-Based Explainable AI, or CXAI. This is honestly a massive leap forward. Instead of an AI just spitting out a diagnosis based on invisible pixel math that literally no human can understand, CXAI expresses its behavior through human concepts. In medical imaging, for instance, it can explicitly point out a lesion or a blood vessel. We should absolutely celebrate this. The AI is finally speaking our language.
But here's the trap. What if the AI is just hallucinating its reasoning? It's kind of like a company publishing a glowing, perfectly formatted financial report. I mean, it looks incredibly professional, the charts are beautiful, the categories make total sense, but what if they just made the math up? An AI outputting a clean, human-readable explanation is exactly the same thing. It can sound completely confident and clinically plausible while completely bypassing the actual evidence. So how in the world do we catch a hallucinating AI?
Section 2. Enter ConceptSmile. Enter ConceptSmile. This framework is essentially our independent auditor, designed to interrogate these AI explanations and keep them honest. It stands for concept-level statistical model-agnostic interpretability with local explanations. Yeah, that's a mouthful for sure, but the core idea is beautifully simple. It's a model-agnostic, perturbation-based auditing framework. Think of it exactly like a forensic financial auditor. If a company claims their expenses are $1 million, the auditor randomly pulls out a few receipts and says, okay, recalculate. If the final number doesn't change, the company's lying about their math. ConceptSmile does the exact same thing to AI imagery.
Let's contrast the traditional approach with this new proposed approach. Traditionally, a doctor looks at an AI's output, sees a vague heat map highlighting some generic area, and basically just has to blindly accept the AI's word for it. The proposed approach with ConceptSmile is radically different. We don't just accept the explanation, we systematically audit it through perturbation testing. We actively mess with the AI's input to see if its logic actually holds up under pressure.
Section 3. How the audit works.
All right, let's break this methodology down into 4 simple steps. Step 1. We extract the concept from the AI, say it claims to see a lesion. Step 2. We perturb the image. We do this by dividing it into superpixels and randomly masking out, or essentially erasing, different regions. Step 3. We measure the response shift. We ask the AI, hey, how confident are you that there's a lesion now? Basically, did the AI even notice we erased part of the image? And finally, step 4. The system fits a local surrogate model, specifically an XGBoost model, to calculate exactly how reliable the AI's explanation actually is based on those shifts.
Let's look at this concept in action. On one side, the AI sees the full retinal image and super confidently identifies that green node, the optic disc. On the other side, ConceptSmile steps in and literally drops a gray mask right over that exact region, totally erasing the optic disc from the image.
So, here is the crucial question. What happens if we completely black out the optic disc and feed it back in? Does the AI still claim it's there? If we completely hide the evidence, but the AI still spits out an explanation claiming it sees a perfectly healthy optic disc, boom, we have just caught the AI in a lie.
The explanation is a hallucination. It wasn't actually looking at the optic disc to make its decision, it was just guessing based on something else entirely. If the AI is actually faithful to its own explanation, its confidence should absolutely plummet the second we hide that evidence.
Section 4. Case Study on Retinal Imaging. To prove this works, the researchers applied their audit to a very real, very high-stakes medical case study, retinal imaging. These retinal fundus images are basically high-res pictures of the back of your eye. Now, diagnosing eye diseases requires an AI to rely on incredibly clear, spatially grounded visual biomarkers, things like the macula, blood vessels, lesions. Because these concepts are so visually well-defined, it makes retinal imaging literally the perfect testbed to see if an AI auditor can actually track whether the AI is looking at the right things.
The researchers set up a really cool experiment contrasting two totally different AI pathways. On one side, you've got MedSam. This is a segmentation model. It physically draws visual spatial boundaries around the things it sees. On the other side, we have a VLM, a vision language model. This pathway uses semantic language concepts, so it basically chats with you about what it sees based on text prompts. They ran ConceptSmile on both of them to see which one was actually more trustworthy.
Section 5. The audit results. Okay, so how did they do? The researchers threw some pretty intense statistical metrics at these models. Let's translate that heavy academic jargon into plain English. The audit graded the AI on 4 main criteria. First up, fidelity. Does our test accurately reflect how the AI behaves? Second, faithfulness, which is the big one. Does hiding the visual evidence actually change the AI's mind? Third, stability. If we toss a watermark or a hospital logo onto the image, does it trick the AI into changing its diagnosis? And lastly, consistency. If we run this exact same test 5 times, do we get the exact same explanation, or is the AI just randomly guessing every time?
And the key findings are really fascinating. Neither AI pathway was perfect. MedSam, the visual boundary model, was way better at mapping distinct spatial structures, like the optic disc. It was super consistent. The vision language model, on the other hand, showed some pretty concerning weaknesses with stability. Get this, when the researchers added a fake NHS logo to the images, the VLM sometimes got distracted and its explanation totally shifted. But weirdly enough, the VLM actually excelled at faithfulness when it came to identifying blood vessels. So the big takeaway here is that reliability completely depends on the specific concept you're asking about and the pathway you're using.
I want to quickly highlight this specific number right here, 0.8503. This was the highest surrogate fidelity R-squared value achieved by the MedSam pathway. What this number mathematically proves is that the ConceptSmile audit works. An R-squared of 0.85 means the auditor's surrogate model could incredibly accurately predict exactly how much the AI's confidence would drop when specific pixels were erased. It means we can successfully map out the AI's internal logic.
And you can see that visually here. These scatter plots show actual versus predicted concept confidence for MedSam and the VLM. Basically, the closer all those little dots are to that red dashed diagonal line, the better the audit worked. You can see MedSam's fidelity is incredibly tight to that line. The surrogate model knew exactly how MedSam was going to react to being perturbed. The VLM, though, a bit more scattered, showing it's definitely a bit more unpredictable.
Section 6. Trust, but verify AI.
So, what does all this data mean for the real world? Why does this matter to you? Well, this right here is what the future of high-stakes AI looks like. This is a concept-aligned explainability report. Notice how every single textual claim, like the optic disc appears clear, is color-coded and 100% traceable to verified, audited visual evidence. A doctor isn't just blindly reading text anymore. They know that the claim has survived the ConceptSmile stress test. If the text says there are hard exudates, the system has explicitly proven that the AI is relying on the pixels of those exudates, not hallucinating them from a random hospital logo.
The authors of the paper hit the nail on the head with this quote: "Concept-based explanations should not be accepted as inherently self-explanatory. They require independent auditing." It's so true. Just because an AI speaks perfect English doesn't mean it speaks the truth. We absolutely have to start treating AI outputs not as undeniable facts, but as claims that need to be aggressively audited and verified.
ConceptSmile gives us a remarkably powerful tool to do just that, stress testing the AI's logic by pulling away the evidence and seeing if the whole story collapses. But it does leave us with a final, pretty provocative thought to take away from this explainer today. As AI gets more and more complex and gets integrated into higher and higher stakes decisions involving our health and safety, if frameworks like ConceptSmile are auditing the AI, eventually who will audit the auditors? Thank you so much for joining me for this explainer. I hope this helps you look at AI transparency in a whole new light.